Greetings everyone. So just going to review how to use the basic trig ratios to solve for a missing side of a right triangle. So just a little review on the concept of SOHCAHTOA. SOHCAHTOA is a mnemonic device that we use to remember the trig ratios that we're using when we're solving for parts of a right triangle. So typically what we have to make sure we identify for any angle in a triangle are which sides are the opposite, which side is the opposite, which side is the adjacent, and which side is the hypotenuse. Now, it's always the case that the hypotenuse is opposite of the 90-degree angle. So there's the 90-degree angle. Its opposite side is the hypotenuse, as already labeled. So that's how you find the hypotenuse. Now, the opposite side and the adjacent side do depend on which angle you're talking about. So I'm doing a reference from angle A right now in the picture. So for angle A, its opposite side is the one, directly opposite of it over here. And so notice that the opposite side is not used to form angle A. Angle A is formed by these two sides right here, the hypotenuse and this adjacent. So the opposite side does not form the angle. The adjacent side is the side with the hypotenuse that forms the angle. So it's the one that's, if you want to say, some might say touching it, some might say forming it, however you want to look at it, that one's the adjacent. But for whatever angle you're talking about, you have to identify all of those three sides. Otherwise, SOHCAHTOA just doesn't make sense, because what the SO part of SOHCAHTOA is that the sine function, which we abbreviate SIN, SIN is opposite over hypotenuse. So for angle A, I would take the opposite side value and divide it by the hypotenuse value, and that would be my sine ratio. The CA part, okay, CAH, well, that's cosine. That's the cosine function. And this is the adjacent side divided by the hypotenuse. So I take that adjacent side and put it in a fraction over the value of the hypotenuse. And the TOA part, that is for the tangent function, which we abbreviate TAN. And then that's going to be opposite over adjacent. And so those are the ratios that you need to know if you want to solve for a missing side. Let's look at an example. So let's say I have this triangle right here, and it's a right triangle because I need a right triangle to use these ratios. I have the angle 30 degrees down here on the lower left, and then I have this x on this vertical side here, and then 18 on this other side. So again, I have to identify what these sides are in relation to the 30-degree angle measure. And so the x is directly opposite of the 30, so this is going to be my opposite side for the 30-degree angle. Looks like I put an APP, that should be an OPP. And then, of course, opposite the right angle over here is the 18, so the 18 is the hypotenuse. And so opposite and hypotenuse, that's going to be the sine ratio. That's the SOH part that we saw over here. And so I'm going to say the sine of 30 degrees is equal to x divided by 18. Now, at this point here, you can do one of two things. You can either use your calculator to find the sine of 30 degrees, or you could first multiply by 18 on both sides to solve for x, and then do all the work in the calculator afterward. So what I like to do is I like to do the multiplication first, or the solving part first. So to undo the dividing by 18, I'm going to multiply both sides by 18. These are going to cancel, and then x is going to be 18 times the sine of 30 degrees, which you'll go do on your calculator. So you just type that in, 18, then hit the multiplication button, and then hit the sine function and 30 degrees. And if you work this out, you will get 9. Here's another example right over here. So in this example here, we have the opposite side, or 20. If you look over here, the x is opposite of the 20. The 9 is the adjacent side. It's not the hypotenuse, because the hypotenuse is the opposite of the right angle. So the 9 forms the angle, so that's the adjacent side over here. Getting a little sloppy, I apologize, trying to hurry. And this is the opposite side. And so dealing with the opposite, that's the x, and the adjacent, that's the tangent function. Tangent is opposite over adjacent. So we'll set up tangent of 20 degrees is going to be equal to x divided by 9. I'm picking up this recording a day later, so I apologize if this seems a little discontinuous. But from here, we need to solve for x. And so to solve for x, we need to undo this division by 9. So I'm going to multiply to undo the division, and I have to multiply on both sides by 9. These will cancel. And then x is going to be equal to 9 times the tangent of 20 degrees, whatever that is. And you're going to need to resort to a calculator to figure that one out. And from the calculator, this works out to be approximately 3.276, if you want to go to that many decimal places. Let's take a look at another example. So in this example here, the side that's unlabeled over here, that's the opposite side, so we're not using that one since it doesn't have a label on it. X is the adjacent side because it helps form the angle with the hypotenuse, and the hypotenuse is 20. So if we go back to our trig ratios, go back to the SOHCAHTOA mnemonic to help us figure which trig ratio to use, then we're going to use the cosine function because cosine is adjacent over hypotenuse. And so cosine of 50 degrees is equal to x, that's the adjacent, divided by 20, that's the hypotenuse. Now, again, to solve for x, we're going to multiply by 20 to undo the division by 20, and we have to do that on both sides. These are going to cancel, and then I get x is equal to 20 times the cosine of 50 degrees. And again, that's something that you'll have to work out on the calculator. And from the calculator, this is about 12.86. Don't forget that decimal point. So hopefully now you have a clearer understanding of how to solve for missing side of a right triangle using SOHCAHTOA. Let's come up with one more example just to make sure you can see a variation that is not uncommon. So let's try this example here. Actually, you should probably pause the video, see if you can work this out by yourself, and then turn the video back on and check your work against mine. So now in our picture here, 49 degrees and the 30 are opposite of each other, and x is the hypotenuse. So opposite and hypotenuse tells us we should be using the sine ratio. So sine of 49 degrees is going to be equal to the opposite, which is 30, divided by the hypotenuse, which is x. This is a little bit different than the other examples because now the hypotenuse was unknown, the variable x, and it's that our denominator is the variable. So it takes a little, one extra step of algebra here. So to solve this for x, there are several ways, but I'll show you one way. I'm going to undo the division with multiplication, so I'm going to multiply both sides by x. The x's will cancel here, and I'm going to get x times the sine of 49 degrees is equal to 30. And since, as I said, I'm multiplying between the x and the sine of 49 degrees, to solve for x, I need to undo that multiplication, and I'm going to divide both sides by the sine of 49 degrees. Whoops. Don't forget the sine. If you do that, then you'll be way off. So now these are going to cancel here, and I'm left with x. And x is going to be this 30 divided by the sine of 49 degrees. That's the exact answer. But for most people, myself included, we need to see a decimal representation to know what that means. So we will go to the calculator and figure out the answer as a decimal. And from the calculator, this works out to be about 39.75. Now, one thing that's worth checking in some of these examples, just to make sure you didn't make a calculation error or enter something wrong into the calculator, the number that I got here, I have to make sure that I understand its relationship to the other number, the other side length in the picture. We should know that x, being the hypotenuse, is going to be the longest side of the right triangle. So the fact that my answer is bigger than the other side given, 30, that's a good thing. That means my answer at least can be correct. If I typed it in wrong and the output came out to be, say, 20, I would have known my answer was wrong because the hypotenuse can't be smaller than the other leg. So then I would go back and check my work or check how I entered it into the calculator because I know the answer would not be correct. So every time you get an answer, it should make sense in the problem, and you should check to make sure that it's a reasonable answer based on the rest of the problem. So in this case here, the fact that my answer for x came out longer than the other side is a good thing, and I know at least it can be correct. If it came out smaller, I know it would absolutely be wrong, and I would go back and fix it. So keep that in mind when you're solving these problems, that you should always check to make sure that the answer is reasonable based on the rest of the information in the problem. Go study.